in this problem, a skier is sliding along on level ground. So they're just sliding along level ground, and then in very nice powdered snow, right? So no friction. That's what we're saying, no friction. And they go up a slope and then back to level travel. So here you go. You got your skier going along, doot, 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 and then they get here. Now, they've gone uphill some, right? But they're still skiing along. The question is, what is this skier's velocity when she gets up here? We know down here what? We know her velocity, right? And up here, what do we know? We know how high she's gone. So we know velocity here. Oh, oh, oh. Velocity is that way. Up here, we're asked what's the new velocity? And the only thing we know is how high she's gone. Well, let's take a look at the conservation of energy equation. Well, first thing we know, she starts off on the low point, so her potential energy at the beginning is 0. We're told there's no friction, so that's 0. But at the end of the problem, she has both kinetic energy and potential energy. So KE1 equals KE2 plus PE2. Let's put in values for this. 1/2 m, and you may notice we don't know her mass, right? It's 1/2 mv2 squared plus mgh. And you'll notice in a lot of these problems, you don't need to know mass sometimes. We're just going to divide mass out, and it doesn't matter at all. And so 1/2 v1 squared equals 1/2 v2 squared plus gh. What are we trying to solve for here? v2. So let's go ahead and isolate the 1/2. I'm going to multiply through by 2 because that'll give me a simpler v1 squared equals v2 squared plus 2gh. And now subtract the 2gh and reverse things around. So I got v2 squared is v1 squared minus 2gh. And v2 then is the square root of. I'm going to get lazy. I'm going to go copy that. I need parentheses. There we go. So v2 is the square root of v1 squared minus 2gh. Let's go over and calculate some stuff. So v1 is what? v1 is 19.3 meters per second. G, 9.81. H, 2.33. So v2 is the square root of v1 squared minus 2 times g times h. v2 is 18.08 meters per second. We started out at 19.3. We're now at 18.08. We lost some kinetic energy and gained potential energy. 18.08 meters per second. And that's it for this problem.